All right, here we go. We got a couple of ideas we need to cover here, being double roots and triple roots. And I suppose you could have quadruple roots and so on and so forth, but the ones we're going to need to be really comfortable with are double roots and triple roots. So a double root would be something like um, if we had x minus 2 squared, remember that would mean x minus 2 times x minus 2. And our roots then would be 2 and 2. So we'd have two of the same root, hence a double root. Now, what's going to happen here, and let's kind of quickly sketch this out. If we had a root at 2 and another root right there at 2, let's pretend for just a moment it was only one root at 2 and one root at, say, 3, just over here a little bit. So let's ignore kind of what we've got going so far. We'd have a function that would come on down, it'd head through the first one, then head back up. And notice that at the two roots, it's going to, beforehand, be heading the same direction as it is afterwards. Okay, and that kind of same idea is going to be what we're going to get with a double root. That just like before, we had two roots, and before and afterwards, it's heading the same direction. This time, we've got a double root. There's two roots right there. And as it comes down, what's going to happen is that the graph just barely touches right on the x-axis. It touches right at 2 and then turns right back around. Okay, it bounces off. Um, this is when uh, it's an even power or an even number of the same root. It's gonna the graph will touch the axis right at that just at that one point, and then it will head back in the direction it came from. And kind of here's briefly kind of an explanation as to why. If we had x minus 2 squared, some numbers just to the left of that root, like 1.9. If we plug those in, 1.9 minus 2, that would be negative 0.1, and then square it, our result would be a positive, 0.01, right? But it would be positive, so it's going to be above our y-axis. Um, since it's squared, though, if we plug a number just on the positive side of it, like 2.1, so 2.1 minus 2, and then square that, 2.1 minus 2, and then square that, so we have 0.1 squared. We get the exact same result. We get positive 0.01, positive. And so on either side of that root, we end up with the same sign. They're both going to be positive. If we had a coefficient of a negative out in front, then you'd kind of have the reverse thing. They'd be heading up. They would just barely touch, bounce off, and head on out, because as you plugged in numbers on the front, you'd square them, get that positive, and then multiply by the negative coefficient, and end up with a negative number. And on the right-hand side, on the positive side of the root, um, you'd plug those numbers in, square it, and get a positive, then multiply it by the coefficient out front, and again get a negative. That's part of the reason why it's going to come up and just bounce, just barely touch, and then head back the other direction. All right, triple roots are similar. This is when you're going to have an odd power, so minus x minus 2, but this time this will be cubed. And so this time we've got an odd power of that root is to an odd power, and so we have let's see, we would have the same similar shape. We've got a root at 2, but where before it was bouncing, think if we had three roots very near to each other, where it came up, headed back down, and then headed back up again, seeing that it's going opposite directions. And we're going to have something similar to that, just all three of those roots are right at the exact same point. So the graph's going to come on up. It's going to start curving in next to the x-axis. It's going to head on through, and then slowly at first, and then head away. So it's got this little hesitation. And if you, probably the best way is to hit that into your calculator, and you'll see that hesitation there. It crosses the x-axis just at that one point, so right at 2. And again, we'd have a triple root, so there'd be 3, a triple root of 2 there. And yeah, but we have this funny little hesitation. It approaches it very close, very slowly, touches it, and then slowly heads out, and then increases in the rate it's going away from the x-axis. Yeah, hope that helped. Thanks.